In this question, you're asked for the wavelength of a photon that has a frequency, or nu, of 5.45 times 10 to the 14 hertz. Hertz can also be rewritten as 1/seconds, or reciprocal seconds. These are all equivalent units. They mean the same thing. You were given the speed of light, which is a universal constant of 3.00 times 10 to the 8 meters per second. And the meters part is important because if you notice, all of the answers that were given to you were in nanometers. So that means we are going to want our final answer for wavelength to be in nanometers. So you need to commit to memory the equation C is equal to lambda nu, where C is the speed of light, which you were given. Nu is frequency, which you were also given. And we're solving for wavelength, which is represented by the Greek symbol lambda. So in order to solve for lambda, you need to do a quick algebraic manipulation where you isolate lambda on one side by dividing both sides by the frequency and rewriting this equation as C divided by nu is equal to lambda. In other words, speed of light divided by frequency is equal to lambda. So now we can plug this into an equation where we write the speed of light in the numerator, 10 to the 8 meters per second, divided by 5.45 times 10 to the 14. Instead of writing hertz, I'm going to write 1/seconds because those are equivalent. And now you should see that these values cancel out the seconds, units, and what you're left with is just meters. And if you plug these values into your calculator, you should get an answer that looks to be about 5.50 times 10 to the negative 7, times 10 to the, 7 meters. Now we need to convert this value into nanometers. And we can do that if we recall that there are 10 to the 9 nanometers in 1 meter, which should give us a final answer of 550 nanometers.